In this video, we're going to be looking at the worksheet that's entitled Interpreting Distance Graphs. You've already looked at a few distance graphs, so we are going to look at a couple more and apply it to a new topic that we're going to be looking at. In this problem, it says, Anne went for a walk on Saturday. When the timing started, she was already traveling at the given rate. She walked in a straight line, away from home. Then she returned back home along the same path. On her way home, she stopped for lunch. The graph shows her distance from home at any given time during the walk. Complete the table and then use the graph and table to answer the following questions. So as we've learned that here is where she's walking away from home. In this case, she goes 3 miles in 1 hour. Then she goes a little slower, but still walking away from home. Picks up the pace a little bit. Decides that at this point she's going to turn around and go back towards home. Then she's going to stop for lunch and then come back home and then slow down a little bit as she comes home the final way. You've already talked about distance graphs, so this is just going to be applying a new topic towards the end. So let's first fill in our distance chart over here. At 0 hours, she is at 0. At 1 hour, she's made it to 3 miles. At 2 hours, she's up to 4 miles. 3, she's up to 8. At 4, she's coming back and she's at 5. At 5, she's come back and is at 5 again. That's where she stopped for lunch. 6, she's at 2. And at 7, she's back to home. So you can see that it really does look like that right here is where she's moved the fastest, because she's gone 4 miles in 1 hour. Here's where she stays still. And we're going to use those to answer the questions. So let's take a look. And at any time, if you need to, you can pause this video. At what time is Anne's distance from home 0 miles? Give a reason that supports your answer. So that would be right here and right here. So she would be when t is equal to 0 hours and when it's equal to 7 hours. And the reason would be, to support that, would be that's when she leaves home and returns home. So 0 miles would mean that she's back home. Number 2 says, what is Anne's maximum distance from home? So maximum distance would be when she gets the furthest away from home. At what time did she turn around to return home? Give reasons that supports your answer. So her maximum distance from home happens right here. That's where it gets the farthest from home. So at 3 hours, she is 8 miles from home. And that is her maximum distance. It says, at what time does she turn around to return home? Well, she turns around at 3 hours. And the reason that is because she doesn't get any further from home. Alright. These are not the only reasons that are possible. You can add your own. But it does say that that's her maximum distance, and then she turns around and comes back home. Number 3 says, when did Anne stop for lunch? How far from home was she when she stopped for lunch? How long did she stop for lunch? Give reasons, support your answers. Well, it looks like that she stopped for lunch at 4 hours, and she was, at 4 hours, she was 5 miles from home. How long did she stop for lunch? She stopped for lunch for 1 hour. And the reason that we have that we know that she stopped for lunch for 1 hour is because the graph doesn't change. And that is because her distance does not change. And then finally in number 4, before we move on to the other page, how many hours was Anne's trip? Give a reason that supports your answer. Well, she started at 0 and ended at 7, so her trip lasted 7 hours. And the reason would be is that's how long it took her to return home. Now, if you will turn to the back, there's another page. I'm going to reference the same graph. I'll have to flip kind of back and forth, but we're going to use the same graph to answer the problems on the back. So turn over to the back. Number 5 says, when did Anne walk the fastest? What was her speed in miles per hour? Give reasons that support your answer. Well, we talked about up here that she walked the fastest from 2 to 3 hours. And that's because she covered 4 miles in 1 hour. She covered 3 miles from 0 to 3, 1 mile from 3 to 4, 4 miles from 2 to 3. Then she did cover 3 miles again, no miles, 3 miles again, and 2. So the time that she walked the fastest was when she went from 4 to 8 miles in 1 hour. So it says, when did she walk the fastest? Well, that occurred from 2 to 3 hours. Into her trip. Her speed would have been 4 miles in 1 hour, which is actually 4 miles per hour. And one reason that that is when she walked the fastest is if you look at the graph right here, it's where the slope is the steepest. So it's where the slope is the steepest. And that tells us when she walks the fastest. Number 6 says, when was Anne walking the slowest? What was her speed? And give your reason. Well, she's going to walk the slowest, and we could look at our table again, right here, from 3 to 4, other than the fact when she stopped, but she walks the slowest from 3 to 4, right here. And the reason that's the slowest is because she only covers 1 mile in 1 hour. And it is the most, or I guess the least steep piece. So we would say, and that was from, look at it again, it was from 1 to 2 hours. She covered 1 mile in 1 hour, which means that's 1 miles per hour. And it's where the slope is the least steep. Or maybe we should say where the slope is the flattest. Number 7 says, what was Anne's distance from home at 6 hours? Give a reason to support. Well, we know that at 6 hours she was 2 miles away. And we'll just use the graph as our reason. Number 8 says, at what time was Anne's distance from home 4 miles? It says to use similar triangles. We're going to actually just kind of make an estimate today, and we'll talk about similar triangles later on as far as how to find that. I'm going to take a little bit off of this graph so we can use it. So distance was 4 is what the question asks. So 4, sorry about that. 4 would be, we've done that before, where you would draw across. We would draw across, and we would see that it happens at 2. And we'll just make a guess here, but about 5.3 or so as our other answer for that one. So for number 8, we would say that happens at t equal 2 and at 5.3 hours. Right? And we did that yesterday also, where we found 4 and we drew across, and we want those output values, just like we did as we did in the graph yesterday. The last are number 9, 10, and 11, are 9 and 10 especially, are what we want to be talking about today. So it says, during what time was Anne's distance from home increasing? Give a reason that supports your answers. So during what times was Anne's distance from home increasing? That means the distance was getting greater. Well, you can see that from 0 to right here at 8, the distance is increasing. And that is from t equals 0 hours to 3 hours. So we would say from 0 hours to 3 hours. And if you look at the graph, the reason is because we have all positive slopes. The graph is increasing, it's going up. So we have positive slopes, which is causing the graph to increase. So therefore, number 10 says, during what times was Anne's distance from home decreasing? Well, that would occur from where all the slopes are negative. Now, technically, her distance are decreasing from 3 to 4, and then from 5 to 7. From 4 to 5, she's staying constant. So we would say from 3 to 4 hours, and then from 5 to 7 hours, and that would be because we have negative slopes. That's where the graph decreases. And the last question says, when was Anne walking at the same rate from home and towards home? That's when the slopes would be the same, and that's when she covers the same distance. So from 0 to 1, from 3 to 4, and from 5 to 6, all go 3. You can write those down.